So Unit 5, that is from January 2022. Questions and MCQs. The first one, a mass oscillating with a simple harmonic motion with about a fixed point O. Which of the following statement about the motion of a mass is correct? Its velocity is always towards O. So whenever, no, it's say this is a mean fixed point is O, like mean position is O. So when it is vibrating, to and fro, so velocity can be opposite, velocity can be towards, not always, so that's not correct. Acceleration is always like whenever it will move towards, it will always accelerate. That's correct. Like speed will always increase towards moving toward the mean position. That is a characteristic of or a definition of a simple harmonic motion as well. That acceleration is always directed toward the center. It will always accelerate when moving towards the center. In an experiment to determine the latent heat of vaporization, experimental data gave a value 2.2 megajoule per kilogram. The textbook value is 2.2. Which of the following explain the difference? So we got the latent heat. Latent heat is energy divided by mass, and energy is power into time divided by mass. So why our value is 2.2? Like our value is smaller than the actual textbook value. That's the question. So some energy transfer, if some energy transfer means like there will be, we have to supply more energy to reach to change the state. So we should get a high value. So this will give a high value, not smaller value, but we are getting a smaller value. The power of the heater is underestimated. Like if we use a underestimate the power of heater, like maybe it's a 40-watt heater, but we use 30. So if the power is less, so the latent heat will be smaller. The student did not stir the water. That does not make difference. Heater is inefficient. If it was inefficient of transferring, so it will be used for a longer period of a time. So the latent heat will be higher. So B is the right answer because if power is smaller, it means the latent heat value will be smaller. In the Pantheon in Paris, there is a pendulum. It takes 8.2 seconds, 8.25 seconds from one extreme position to another. So this is not the time period, this is a half time period because from one extreme to another and then returning back, that will be the total time. So if we need the length of pendulum, T is equals to 2 pi under root L divided by G. If we square both sides, so this will be T square is equals to 4 pi square L by G. If we need length, so it will be T square multiplied by G divided by 4 pi square. So time period, it should be 16.5. Why 16.5? Because from one extreme position to another extreme position is a half time period. Multiplied by gravity, 9.81 divided by 4 pi square will give us L. So it means it matches with option D. Tritium is a radioactive isotope. Wine may contain trace of this 125-year-old bottle of wine were found to have an high activity 22 becquerel. The half-life is 12.5. Which of the following gives the activity when it was bottled? Like we need the original activity. So we have the formula A is equals to A naught e raised to power minus lambda t. Or the value of a lambda is equals to 0.693 over t half. This will give us the value for lambda. And we need the right now its activity is 22 becquerel, like this is 22. We need the original activity, A naught we need. So we just have to substitute like first 0.693 over 25 because the unit of a time, like it will be 2 years inverse. And this is 12. The half-life is in years, so this should be year inverse. It won't make difference. So this will be 22. A naught we don't know. e raised to power 0.693 over t half, which is 12.5, multiplied by the 25. So this will be 25 because like 125-year-old bottle wine. So before 25-year bottle, like this is a activity after. We just have to simplify this, like taking ln both sides. So ln 22 is equals to, or you can like ln a naught plus ln e raised to power 0.693 divided by 12.5 into 25. And you can get the original activity. This is one way, which is the formula method. There's also, like, you just have to mathematically solve the equation and get a naught. There's also another way. 25-year bottle wine, so means this is 25 years old. So half life is, so before 12.5, what, like right now it has an activity of a 22. So before 12.5 years, because half life, it will have an activity of 44 becquerel. And then before 0 year, like means like the beginning, it will have an activity of 88 becquerel. So you will get C as the right answer. Like if you start with original 88, after 12.5, it will be 44. After another 12.5, it will be 22. This is one way, or another way is a formula which I use. You can use any of them to get the answer. Both will give the same answer. A fixed mass of an ideal gas has a volume V, exert pressure P, the temperature. When the gas is heated, new pressure is 4P. Which of the row? New volume and new temperature. And what is constant pressure? Absolute temperature is T. So we have the formula like P1 V1 over T1 is equals to P2 V2 over T2. So the first pressure example P, the first volume is V and the first temperature is T. The final should, this is 4P. So what should happen to V? Because the total, we should get the same. Like example, if we say that the volume is double according to the first one, or volume according to the first one, volume will be half. So this will be V by 2 and temperature is 2T. So if we simplify this, you can, if we simplify like this, 2 will cancel with 2 here. This will be 2 and 2 cancel here too. So means the initial and before will be same. So means these factors matches. Otherwise, if you check with other one, like PV over T, the new pressure is 4P. So new volume, according to this, is, it is V by 2. And new temperature is 4T. So V will cancel with this 2, and this will be 1, and this will be 2. So means this side will be PV divided by 2T, and this side is PV over 2T. So they are not equal. So means this, any other will not match. Only A will match. The left hand side and right hand side will be equal. So when all the three factors are changing, you can use P1 V1 over T1 equals P2 V2 over T2. Current theory suggests the universe is expanding. Which of the following is evidence to support this? Like how we can say the universe is expanding? All galaxies appear to be rotating in space. That does not give an idea. Dark matter, if a dark matter is detected, dark matter means the gravity should be stronger, so universe expansion rate should be slower, or the size of universe should be smaller. All distant stars are observed to be increased in size. they are not increasing in size. The distant star or galaxies appear to move away from us. The further the galaxy from the Earth, the faster it recedes. Like the recession velocity is directly proportional to the distance. Those galaxies which are far are moving much faster, which is also the Hubble's law. A student investigated the absorption of the gamma radiation by lead. She determined the background radiation before starting the investigation. Which of the following is not affected by her? Which of the following would not affect her value of a background radiation? The place where she made the measurement, um, like student investigating the absorption of a gamma radiations by lead. And she determined the background count rate before she start. Like she determined the background counts before she start. So affect her, which of the would not affect her value of a background? The place where she made the measurement. So the place where she made the measurement, that will affect because the background count depends from region to region. The background count changes. The temperature, because the radioactivity is a random and spontaneous process. It is not affected by external factors or condition. The time interval for a background count, if you record for different interval, she will get different background counts. Type of radiation detector use, that will also affect the background count. So the temperature or the pressure of the surrounding, because the radioactivity is a spontaneous process, so they are not affecting the background radiation. Centauri and Ceres are the two our closest stars are there. Its luminosity is 16 times greater and its size is it's twice far as the Earth. The intensity of a light compared to that. So intensity, if you want to compare the intensity, it is luminosity divided by 4 pi d square. So it has 16 times luminosity. So if the luminosity increased by 16, this will also increase by factor 16. And the distance is twice far. If a distance is double, so what happened? This will decrease by 4. So increase by 16 and decrease by 4. So 16 divided by 4, what we get? We get 4. So it matches with option B. Question 9. The spectrum of electromagnetic radiation from the galaxy is observed to have redshift. Which of the following is a correct statement about the lines in the spectrum? So when we have a redshift, all the lines are red. No, that's wrong. Like it's not like all lines are on a red part. It means they shifted. All the lines are observed to have longer wavelength. Like say these are this is a line spectrum we get. This side is example violet and red. But or this side example red and here violet. When we observe the same spectrum but shifted more towards red. So all the lines are observed to have a longer wavelength than the expected value. The graph shows how the binding energy per nucleon depends on the range of naturally occurring nuclides. Iron is having the highest binding energy per nucleon or the most stable nuclei. Which of the following can be deduced from the graph? Iron does not undergo its stable fission release and less energy than fusion. No, actually fission because it's a chain reaction is there. So it does not give an idea about high mass cannot undergo fusion. High mass nuclei means like nuclei, this region as well. It's not like mostly high mass is here, nucleon number, but high mass, which of the following deduced from the graph what we can deduce? Low mass nuclei release energy during fusion, because how we deduce from the graph, whenever the binding energy increase, like example, hydrogen is there converted into helium. If the binding energy per nucleon increase, so what will happen? Energy will be released to the surrounding. And same thing, uranium converted into lead by multiple fission. So the binding energy, or convert into barium or krypton. So the binding energy per nucleon increase, so means the energy will be released. So for C, high mass nuclei can undergo a fusion, but we have to supply energy. It will be endothermic rather than exothermic.